Hi everyone, welcome back to another continuous time linear problem, and today we are going to be recorrecting for our problem set 5.1 equation, where before what we ended up doing was solving for the Fourier transform x of j omega by using the table, but now we're going to show you how to actually do it out. So, and then for our part B, our goal is to find the inverse Fourier transform y sub t. So in order to do that, we're gonna use our game plan, where our goal is to use the Fourier transform equation and the inverse Fourier transform equation. So let's get straight into it. For solving for the Fourier transform of x of t, we're going to use our Fourier transform equation, where we are evaluating the input x of t from negative infinity to infinity. So when we plug in our x of t, our u of t goes to 1. So that forces our integral regions to change from 0 to infinity, positive infinity. From then on, we evaluate the integral and we substitute j omega plus 5 to u, so that way it's just easier to solve. From then on, when we evaluate our integral, we're evaluating our integral from infinity from 0 to infinity. So then we use one of our simple properties. When we plug in e to the minus infinity, that just goes to 0, and when we plug in e to the 0, we get 1. So when we plug it in, we have 0 minus 1 minus 0 minus 1 over minus u. So from then on, we just get 1 over u, and all we're gonna do is substitute it back into our equation for us to get 1 over j omega plus 5. So now that's how we solve for the Fourier transform. For the inverse Fourier transform, we're essentially going to be doing the same thing, where we're going to be plugging in our y sub j omega and evaluating it from negative infinity to infinity. As you can see, omega is y sub j omega is 0 when it's negative infinity to minus 100 pi, and negative 100 pi to positive infinity. So that's why we have 0 right here. When we evaluate our integral, we still do the same substitution of u, so that way we get it simpler. And then we use our Euler's identity to get our e to the j 100 pi to our sine equation. And then when we change that, all we get is sine 100 pi plus t over pi t. And what that is a sinc function. So then we can evaluate it as the Fourier transform of a low pass is just the inverse Fourier transform is a sinc function. Well, thank you. Come again.